Today we're looking at Glencoe Accelerated Math Lesson 8.8, which is on solving multi-step inequalities and equations. So we know how to solve if we have a variable plus or minus some quantity. We know how to solve if we have some number of a quantity or some number of a variable set equal to or in an inequality compared to something else. We know how to solve if we have both of those things. We know how to solve if something is written in factored form, so we have something times a quantity. Well, today we're going to be putting several of those things together. Okay? So, let's see what this looks like. If we had the equation x plus 250 equals 15 times 2x plus 1. Okay, so we've got variables on both sides. I have two factored forms in my equation, and I have a decimal. First thing we're going to do is distribute if necessary. Okay? So I'm going to start a little checklist. Start with this, then this, then this, then this. If something doesn't apply, skip that step. So step 1, we're going to distribute. So that means that I have 20 times x plus 20 times 2.5 equals 15 times 2x plus 15 times 1. And we simplify. So that's 20x plus 50 equals 30x plus 15. Everybody with me so far? Yeah? Okay? Step 2. Step 2 that we're going to use is going to be combine like terms. In this problem, we don't have any like terms that we need to combine. But we could have had 15 times the quantity 2x plus 1. We could close that quantity, then say like plus 12. Or we would want to combine the 15 and the 12. So we don't have to do that step this time. Step 3. Transfer variables so that they're only on one side of our equation. I'm going to call that relocate variables. So you know that I said I prefer to move the number that has a lower quantity of the variable. So I'm going to subtract 20x from both sides. That leaves me with 50 equaling 10x plus 15. Step 4, we remove our outliers. So here we would subtract 15, leaving us with 35 equals 10x. And lastly, we're going to remove our attachments. which says I divide both sides by 10. So 3.5 is equal to x. Take a second. I see a number of us writing it down. That's a good idea. Yes, ma'am. Yes. So, as we're doing this, what questions do we have? Do we know what our questions are yet? We don't know what they are yet? Okay. Would re-explaining be helpful? Okay. So, in the black ink, we did step 1, which said that we wrote the problem. We know we have to write the problem. We then distributed 20 to the quantity x plus 2.5, and we distributed 15 to the quantity 2x plus 1. To do that, I multiplied the number outside of the parentheses by what was inside. Remember, that number outside has to be multiplied by everything inside, not just our variable term. However, that strength is not strong enough to go past that end parentheses. Okay? We didn't have any like terms that we had to combine after doing that. So then, we relocated our variables so that we only had a variable on one side of our equal sign. To do that, I subtracted the 20x from the left and on the right, leaving me with 50 equals 10x plus 15. That's the format of our two-step equation that we're familiar with. Then I remove the outliers. That's a number that's not attached to the variable, but that's on the same side as my variable, leaving us with 35 equal 10x. And last, I remove my attachment, which is a number that's left on the same side as my variable. Dividing by 10, that left me with 3.5 equaling x. Better? Little bit? Okay. Any questions about this? We're going to do another example. I'm not setting you free yet. Okay? Okay. Can I erase? Yes? Okay. Okay. So if we look at example 2, example 2 says 3 times the quantity y minus 5 closed quantity plus 25 equals 3y plus 10. So, the first thing I want to know is this. Do I need to do step 1? Yes. What do I have to distribute? What quantity am I distributing? So what number is getting distributed? The 3. Okay, so we're going to distribute the 3. What are we distributing the 3 to?
Y and 5.
The y and the negative 5. So that's 3 times y plus 3 times negative 5. Do I multiply the 3 by 25? No. No. Let's go ahead and simplify this. 3 times y is
3y.
3y. 3 times negative 5 is negative 15. Plus a positive 25 equals 3y plus 10. Alright, do I need to do step 2?
No. Yes.
No.
Yes. What are the like terms that I can combine? Not yet.
Negative 15 and 10. Or 10 and 25.
Negative 15 and 25.
The negative 15 and the 25. Okay. What is negative 15 plus 25?
10. Oh, it's 10. It's 10.
Okay. All right. Now. What?
Y equals y. 10 equals 10.
The solution, listen. The solution to this is actually the set of all numbers. So that actually means that there's an infinite number of solutions here. Okay. But
Y could be any number.
and that means that y could be anything.
Because
Because they're the same. But to get there, while we might recognize that here, what we actually need to do, we still need to relocate our variables. So minus 3y, minus 3y. Does it matter which side we're technically removing from? No, because they're the same. They're going to get removed on both sides. Excuse me. And we're left with 10 equals 10. Alright? Not yet. What? We can stop here. We don't have to get to 0 equals 0. Okay? Alright. What? But we actually can't divide by 0 because dividing by 0 is undefined. Okay. Ladies and gentlemen, because we seem to be having some discussion about this, what I'm going to ask you to do I want to know why do you think we did this example? Let's think for just a second. Why did we do this example?
Show what would happen if they're equal on both sides.
Right. To show that they can be equal. To show that this can exist. We did this because there will come a time when you have to be able to tell me how many possible solutions there are. Okay? I would like to do one more because we can also do this with inequalities. Were there any questions about this example before we move on? Okay? Am I safe to erase?
Yes.
All right. The other example is this. On page 376. Example 5. Can someone please read that example to me? I'm sorry, what is it?
5a minus 8 is greater than or equal to 4 parentheses 8 minus 3.
Alright, you said is greater than?
Yeah.
Okay. Did I write it correctly? Yes?
Where does the word greater than come from?
What?
What?
There it is. For example 5?
Oh. I wrote down example 3.
Gotcha. We're on example 5.
Come on, Nick.
No names. Alright. So, first question that I have, do I need to do step 1? Yes. Okay. What am I distributing? The 4. What is the 4 being distributed to? A negative 3. So I have 5a minus 8 being greater than or equal to 4 times a plus 4 times negative 3. Alright, can this be simplified? Yes. 5a minus 8 is greater than or equal to, what's 4 times a? 4a. 4 times negative 3? Negative 12. Okay. What is step 2? Step 2 tells me to combine like terms. On each side of my inequality, are there like terms to combine? Don't look at me. I don't have the answer. Can I combine these? Can I combine these? So do I need step 2? No. Alright. Step 3, relocate variables. Do I need to relocate any variables?
Yes.
Yes. Because I need all my variables on one side of that inequality symbol. Okay? So we're going to relocate the 5a or the 4a?
5.
So here's the thing. If we relocate the larger quantity of the variable, then we're going to end up with a negative variable that we have to deal with later. If we relocate the smaller variable, we can leave it with a positive variable, and that's a lot easier to deal with. Okay? So, we're going to relocate the 4a. Now, I will say this. You'll eventually get to the same value because the variable is going to be equal to the variable no matter what. But it's a lot easier this way. Okay? So, 5a minus 4a gives us a minus 8 is greater than or equal to negative 12. Okay? Now what do I need to do? Add a to both sides, which is what step? Step 4. Removing my outliers. Negative 12 plus 8 is? Negative 4. So, can I do step 5? No, I don't have any attachments left. By relocating my variables, my attachments disappeared. Alright? Now, inequalities, is it likely or possible at all that you would be asked to graph the solution set? Yes. And graphing the solution set means what?
Number line.
We're going to put it on a number line. So, without actually doing it, where would my point go for this problem? -4. Would my point be open or would it be filled in?
Filled in.
Filled in. Would my arrow go in the positive or in the negative direction?
Positive.
Positive direction. Why is it positive?
Because A is bigger.
Because the variable is greater. Okay. Does anybody have any questions for the good of the group about what we've done today?
No.
No. Does everybody have our steps written down somewhere? All right. Are you going to be color coding what you do?
No.
Yeah. Okay.
Let's do our work in pencil. So we're not color coding? All right. You guys know I like to color code so that you can see what each step looks like in the example. Okay? I think that's all I got for you today. Thank you.